Ever wondered how to navigate the labyrinth of nonlinear data? Think of it as a winding road, full of unexpected turns and twists. In the realm of statistics, we often deal with nonlinear data, sets that don't follow a straight line when plotted on a graph. It can be a bit of a head-scratcher, right? But don't worry. Understanding nonlinear data is crucial because it occurs in many real-world situations. From the fluctuating stock market to the growth of bacteria, nonlinear data is everywhere. And here's where the concept of data transformation comes in. It's like our compass, guiding us through this winding road. Data transformation can help to simplify the complex, making nonlinear data easier to analyze, understand, and predict. So are you ready to unravel the mystery of nonlinear data? Buckle up as we dive into the world of nonlinear data and its transformation. Imagine a world where nonlinear data bends to your will. Welcome to the realm of square transformations. Square transformation is a powerful tool that shapes nonlinear patterns in data into something more linear, more manageable, enabling us to dig deeper into our data. Just as the name suggests, it involves squaring each data value in a given dataset. Let's walk through a simple example together. Picture a dataset where the relationship between variables seems to curve upwards, forming a parabolic shape. This is a classic case where a square transformation can help us out. So how do we go about it? We take each value in our dataset and square it. That's it. That's the magic of square transformation. If we had a value of 2, we square it to get 4. A value of 3 becomes 9, and so on. Once we've squared all our values, what we're left with is a transformed dataset. And here's the exciting part. When we plot our transformed data, we'll often find that what was once a curve now more closely resembles a straight line. But why does this happen? Well, squaring increases the separation between larger numbers more than smaller ones. This has the effect of stretching out our data, particularly on the higher end, and that can help straighten out a curve. Square transformation, therefore, is not just about number crunching. It's also about reshaping our understanding of the data. It's about giving us a fresh perspective, a new way to interpret and analyze our data. And let's not forget the practical applications. In areas like statistical modeling, where linearity is often assumed, square transformations can be a game changer. They can help us uncover relationships and patterns that might have been missed in the original nonlinear data. Just like that, square transformation gives us a new lens to look at our nonlinear data. Ready to add another tool to your data transformation toolkit? Meet the logarithmic transformation. This mathematical marvel is all about base 10, where we transform the data by taking the log of the original values. The logarithmic transformation, or log transformation for short, is a powerful tool for turning nonlinear relationships into linear ones. What makes it so special? It's all in the magic of base 10. In a logarithmic transformation, each increase by a factor of 10 corresponds to an increase of 1 in the log value. This makes it an extremely useful tool for dealing with data that spans several orders of magnitude. Let's go through an example. Suppose we have data that spans from 1 to 1,000. In its original form, this data is nonlinear and hard to interpret. But when we apply a logarithmic transformation, we turn this wide range into a manageable scale from 0 to 3. It's the difference between trying to comprehend the size of a galaxy and understanding the layout of a city. Both have their place, but one is much easier to navigate. So, how do we perform a logarithmic transformation? It's simple. We just take the log of each value in our dataset. This can be done easily with any scientific calculator or spreadsheet software. Just remember, the base of the logarithm should always be 10. The benefits of logarithmic transformation go beyond just simplifying our data. It can also help in identifying patterns and relationships that may not be obvious in the original data. It's like having a decoder ring for nonlinear data. In the world of statistics, logarithmic transformations are often used in regression analysis and other predictive modeling techniques. They are also commonly used in scientific research, especially in fields that deal with exponential growth or decay, such as biology, chemistry, and economics. With logarithmic transformations, our nonlinear data is no longer a riddle. In the world of data transformation, sometimes, the best move is to flip things around. Enter the reciprocal transformation. This is a powerful tool, particularly when dealing with data that has a hyperbolic shape. The reciprocal transformation is the act of taking the reciprocal or the mathematical flip of each data point's value. In other words, if you have a data point with a value of 2, its reciprocal would be 1/2. Picture this. You're studying the relationship between the speed of a car and the time it takes to stop. The data is scattered all over the place, forming a curve instead of a straight line. What do? Well, you can use reciprocal transformation to turn this curve into a more manageable shape. Here's how it works. If the original stopping time was 4 seconds, the reciprocal would be 1/4 or 0.25. Do this for every data point, and voila! You've got yourself a set of transformed data that's easier to analyze. But why would you want to do this? Great question. Reciprocal transformation can help to linearize data, making it easier to analyze and interpret. It can also stabilize the variance of a dataset, which is vital when you're dealing with data that has a lot of ups and downs. But remember, it's not a one-size-fits-all solution. Reciprocal transformation is most effective when the original data follows a hyperbolic pattern. If your data doesn't fit this shape, a different transformation might be more appropriate. And lastly, be mindful of zero values. Since the reciprocal of 0 is undefined, you'll need to figure out how to handle these cases. Some statisticians add a constant to all values to avoid this issue, but it's crucial to consider the impact this could have on your data. So there you have it, the reciprocal transformation, a simple yet powerful means to make sense of nonlinear data. It's like having a magic wand that can turn a chaotic scatterplot into a neat, orderly line. Reciprocal transformation, a game changer in our quest to understand nonlinear data. Now that we've explored the terrain of data transformation, it's time to gather our findings. Let's take a moment to reflect on our journey through the world of nonlinear data and the transformation techniques that help us understand it better. We kicked off our adventure with the square transformation. This technique allows us to mold skewed data into a more linear form, making it easier for us to decipher patterns and trends. By simply squaring our dataset, we give ourselves a clearer, more manageable view of the information at hand. Next, we delved into the magic of base 10 with logarithmic transformation. This method is particularly effective when dealing with data that exhibits exponential growth or decay. By applying a log transformation, we're able to tame this data, rendering it into a linear shape that's much simpler to navigate. Our final stop was the reciprocal transformation, a method that quite literally turns the tables on nonlinearity. By taking the reciprocal of our dataset, we can transform hyperbolic relationships into linear ones, making our data more palatable and easier to analyze. So, why go through all this trouble to transform nonlinear data? The answer lies in the simplicity and clarity that linearity offers. Linear data is easier to understand, interpret, and predict. It's like turning a winding, convoluted path into a straight, easy-to-navigate road. Data transformation allows us to simplify complex relationships and expose hidden patterns, ultimately empowering us to make more accurate and informed decisions. In essence, data transformation is a powerful tool in our statistical toolbox. It